Hello everyone, in this video we are going to look at Python decorators. So what is decorators? It allows the programmers to modify the behavior of a function. We can add some extra functionality to an existing function. Now how it does? So decorator allows us to wrap another function in order to extend the behavior of the wrap function. So what happened here? We will have two functions. One is the original one, and along with that we can add some extra functionality using a wrapper function, and that all can be done without modifying our original function. Before it explain how decorator is written, let me go through some basic examples of Python functions. Alright, here's a simple Python function which will add two value and take two parameters and return the value after adding it. And we have made a function call to that using a value 3 and 4. So that's how a function call is made to use the function. Now if I execute it, and you will see that value 7 is returned. So in Python we can assign the function to another variable also. To do that, I will create a variable fadd and we will assign the function add to that variable this way, fadd equal to add. So now instead of calling the function add, we can call the fadd function fadd with the name of fadd, which will do the same thing as earlier. So if I show you here, okay, so it will return the same value 7. As you can see, the variable fadd also pointing to the function add, right? So this is the first functionality. Another functionality is that we can take a function name as a parameter. Like here, as you can see, x and y is a parameter, which is a numeric value we are passing here. Instead of numeric value, we can pass a function name itself. So for that, let's see another example. Here we have taken a list and we have made call using a function called convert list. Now this convert list takes a parameter as a the convert list takes a function as an argument. So here what we do, using the convert list function, we are finding either square of a number or cube of a number, right? So for that we have two more function called square and cube, and we pass this function to the convert list. So this could be according to our need. If we need to calculate the square of the list, then we will pass the cube function. If we need, we will find we will pass the square function, or if we need to create a cube of the list, then we will pass the cube function, right? So inside the convert list we have maintained another we have created one empty list, and we loop through the list and append each of the calculated value in that LQ list, and we are returning that one. So if the convert is a square, it will find a square of the number. If it is cube, it will find a cube of the number. So let's see the visualization. So as you can see, the first one is a square, that's why it is returning the square number of these values, and here the cube values, right? So with that being discussed, let's see the last method, that is returning a function. To returning a function, we will use two functions, right? So we will use outer function, which will take no parameter, and we will assign a variable here. Let's make it smaller. And after that we will declare another function called inner, and this inner function will simply print the message that is declared here. Being inside of the outer function, this inner function will also have the access to this message, right? Because this and this are in the same scope. Okay, so And what outer function will do, it will return the inner function, right? So now we need to make a call to the outer function to see the result. So let's do this, and outer function call will take us to the outer function definition, and the message hi, then returning the inner function, right? So it will print the function hi, right? So let's go ahead and let's define let's change it to a function name instead of a function call. So in that case, what happened, we are returning the name of the inner function. It means the outer function definition needs to store that value in a variable, right? So let's store it in a variable called result, and later we need to call the result variable. Okay, so what is happening here? We return the name of the function, means the outer will return the name of the inner function. So the result will be our inner function. So that's why when you call to the result, then it will eventually call the inner function. So let's see the visualization here. The outer definition, then the message, then the definition of inner, then we are returning the name inner, right? So the return value will point to the inner function, which will be held in the result variable. See, and now we are making a call to the result, which will go to the definition of the inner method, and eventually print the message, right? So this structure we will use in our decorators also. Now here, to make a decorator, we will need another function, right? So before we go to the defining a decorator, let's modify this. Let's make it a little bit crisp. So we no need this line also. What we can do, we can make such a way that our outer function take accept one parameter, and that parameter we can write as hi outside. So these changes will not change the flow of the execution. Just instead of taking defining another variable inside, we are taking a parameter. Okay, so now we will define here another function called display, and this will do a simple output. So it will simply display a message, printing from display. That's it. Alright, so now what we'll do, instead of the message here, we will pass this display function. Now inside the inner function, as we are changing it to a function, the message to a function instead of a string, instead of printing, we will make a function call. Ultimately, here we are working with, using this print statement, we are actually working with the parameter. So here also we will do the same, just we will make it as a function call, right? So this is the basic layout of a decorator, where we have created a function display, and this function we pass to another inside the decorators, which execute the function, and before the execution or after the execution we can add some more functionality. So let's do that. So print printing from inner function. Oops, sorry. Okay, and then we will execute this message function, and then the definition of inner will first print something which is a other functionality, and then we are executing our display function, which is a message here, as message here, and the outer function will return the inner, right? So let's go ahead and see the visualization. The outer definition, then the display definition, and now we are making a call to the outer function by passing the display function. So the message MSG will point to the display function, and then inner definition, and we are returning the inner, right? So now the result will contain result and inner is same now. So when we make a call to the result, it will eventually call the inner method, right? So now it will go to the, it will execute the inner definition, and we will print this line, and then we make a call to our display function, so it will print the next line. All right, okay, so as you can see, we have add one functionality, something we have worked something before the display function, before the printing statement of the display function, right? So we can do the same after it also, like we can write print printing after okay. So this is the display function, right? So let's see the visualization again. So here the message.name eventually represent the display function, right? We are passing here the function display. So msg underscore underscore name eventually give us the name of the function passed here. All right. So as you can see, printing after the display function. Okay. So this is the basic structure of a decorator, where we passed a function to add some functionality. To make a call this way is a little bit messy, so that Python has given us a way to do it in a better way. So we can use the address symbol before the defining of the function. So if we want to apply decorator to this display function, what we'll do, before this display function, we will use the address symbol and the decorator function name. In this case, it is the outer function, and this we can get rid of these two lines, and here simply we will call the function display. So this is a very simple way to apply decorator to any particular function. So like that we can use it to multiple function, right? So let's say by function, right? And here we are printing by logic. This function not required to have the decorator, but for the sake of to show you the use, actually I'm going to use the decorator here also. And then we are calling the both function display and say by. Let's see the visualization. So what should happen here when we are getting printing from display? So when this display function is called, before this printing from display, this line should get printed, and after this line, this printing after this function should get printed. Same as say by also. As we have applied the decorator here, before this by line, there should be printing from inner function, and after by line this statement should display. Okay, so let's see the output. So this is the output from the display function, and this output from the calling of the say by function. Alright, so this is the function, this is the concept of a decorator, which we can use in when we need to add functionality to our existing function. Thank you for watching the video.